Okay, example 3, we are going to use this theorem 1, which is the power rule, which is a very robust rule for taking derivatives. If we take the derivative of x raised to some power, this can be any real number, anything you want. Then you take that number and you multiply it and change the exponent by reducing that number by 1. That's the power rule. So for example 3, the derivative of x cubed is 3x squared. We take the 3, move it down, and then subtract 1 from the original power. If you have something like a fraction, you have to do the arithmetic of the fractions. So this would be 1/2 minus 1 is negative 1/2. For C, we're going to have negative 4, so the whole negative comes with it, the whole number comes down, x minus 5. Negative 4 minus 1 is negative 5. For part D, this one's a little bit, pi is a real number, right? Pi is a real number, so this would be pi times x to the, there's no nice way to rewrite that. You just have to write it as pi minus 1. Okay. Before we head into example 4, let's just mention theorem 2 here. The derivative is essentially a limit of slopes. So because it's a limit of slopes and limit is a linear operator, it means that it behaves what we'll say, or what we'll call, is nicely. So essentially, you can distribute the derivative through a sum. So if you have two things added together, you can take the derivative of each and then add the answers together. Also, if you have a real number multiplied by your function, you can simply move that to the outside and then differentiate your f. Or another way to think about it is just take the derivative of the function and then multiply the result by that constant. You don't actually have to do this literal switching of positions. You can if it helps you, but really this rule is just saying you're allowed to the derivative of a scaled function is just the scaled derivative of that function. So, for instance, down here in example 4, let's take a look at f prime of t. So here is an example of that. We know that a t squared on its own, its derivative is just 2t. But we have this extra copy of 2 here. So we'll have to take our 2t and multiply it by 2. So this would be 4t. So now a term like this, it would probably be useful to take this term and rewrite it as negative 3t to the negative 1. Because there's something that this power rule says in mathematics, but oftentimes gets overlooked. This x to the n is not in the bottom of a fraction. So if you have something like 1 over x cubed, the derivative of this is not equal to 1 over 3x squared. That is not true. That's not following the rule here. This is saying this only acts in the bottom. That's not true. So what you'd have to do actually is you would have to first rewrite this as x to the negative 3. Now this is written in this same format here. Now you can go ahead and get your answer. So taking that down here, it looks like the derivative of this term here would be negative t to the negative 2, but times negative 3, so this would be, this would be plus 3 t to the negative 2 because of that double negative. Over here, negative 1/3, they kind of connected, didn't they? Negative 1/3 t to the, we have to subtract 1, so this would be negative 4/3.